There is a category of household goods that cost under $50 right now and will shield your family from the next wave of retail inflation permanently. Not stockpiling, not hoarding, not panic buying. Strategic acquisition of items that hold value across decades because they were designed before planned obsolescence became doctrine. In 1860, a British chemist named Frederick Walton patented a floor covering that lasted 40 years without replacement. Hospitals used it, warships used it. Then, in 1952, a boardroom in Wilmington did the math on a flooring industry that could generate $12 billion annually if customers replaced their floors every 7 years instead of every 4 decades. The natural formula quietly left the catalogs. This is the story of durable goods acquisition in an age of engineered fragility. The things your grandparents bought once and your children inherited. Welcome back. I'm glad you're here. Walk into any home built before 1940 and open the cabinet under the kitchen sink. You will find cast iron, not coated, not enameled, bare gray metal that weighs 11 pounds and has outlasted 3 generations of homeowners. The Romans understood this principle at scale. In the 3rd century, aqueduct engineers in Gaul specified lead-free bronze fittings for water systems because they knew those joints would serve the empire for 500 years. They were correct. Archaeologists at Nîmes in southern France excavated sections of the Pont de Gare in 1987 and found original bronze valve assemblies still functional after 17 centuries. The Romans did not replace infrastructure. They built it to endure. Move east to China during the Han Dynasty, around 200 BC. Ironworkers in the Yellow River Basin were casting woks in sand molds, pouring molten metal at temperatures exceeding 2,000 degrees Fahrenheit. A properly seasoned Han wok, if it survived the centuries, would still distribute heat more evenly than any modern nonstick pan. The key was thickness. Han metallurgists used iron 3 times thicker than contemporary cookware because they were not optimizing for shipping weight or material cost. They were optimizing for thermal mass and longevity. Families passed these woks down through generations, the carbon steel surface growing darker and more nonstick with each decade of use. Jump to medieval England. In the scriptorium of a Benedictine monastery in 1220, a monk is trimming a goose quill with a knife his grandfather forged. The blade is high carbon steel, hardened in brine, tempered over a low fire until the spine turned pale straw yellow. That knife will still hold an edge in the year 1300. The monk knows this because the abbot's knife, made by the same process 80 years earlier, still shaves hair off a forearm. There was no planned obsolescence in 12th century Europe. Metal was expensive. Labor was expensive. You made a thing once and you made it to last until your grandchildren buried you. Cross the Atlantic to the workshops of New England in 1790. A cooper in Boston is assembling a barrel from white oak staves, each one split along the grain and shaved with a draw knife. He uses no glue, no nails, only the compression fit of wood swelling against iron hoops. That barrel, if kept wet or kept dry but never cycled between the two, will hold liquids for a century. The cooper knows this because he has repaired barrels his grandfather made in 1720, barrels that held whale oil and rum and molasses for 70 years, before a hoop finally rusted through. The modern 55-gallon drum, by contrast, is rated for a 5-year service life before the rolled seams begin to weep. Now picture a Japanese swordsmith in 1800, working in a small forge outside Kyoto during the late Edo period. He is folding steel, hammer blows, ringing in a rhythm unchanged since the Kamakura era 5 centuries prior. The core of the blade is low-carbon iron for flexibility. The edge is high-carbon steel for hardness. The transition between the two is a diffusion bond created by heating and folding the billet 15 times. That sword, if cleaned and oiled twice a year, will still cut cleanly in the year 2000. There are katana in private collections today, forged in 1500, that remain fully functional. The swordsmith was not designing for a replacement cycle. He was designing for immortality. Before I go further, everything I just shared is barely the surface. I spent months collecting the techniques the retail industry does not want you to know. How to restore cast iron that looks beyond saving using a single chemical in a trash bag. The Depression-era method for waterproofing canvas that outlasts every modern spray treatment. The specific type of wool blanket issued to Arctic explorers in 1912 that still regulates temperature better than synthetic fleece. The reason pre-1960 furniture joints never needed wood glue. The farmer's trick for keeping hand tools rust-free in humid climates using nothing but a coffee can and a candle stub. All of it is inside, vault name. Link in the description. But stay right here. The science behind what comes next is going to make the consumer goods industry deeply uncomfortable. In 1951, an American industrial designer named Brooks Stevens stood in front of the Society of Automotive Engineers in Detroit and delivered a presentation that would reshape the entire manufacturing economy. He called it planned obsolescence. The core thesis was simple. If you design a product to fail or become unfashionable within a predictable window, you convert a one-time purchase into a recurring revenue stream. Stevens was not inventing the concept. He was naming and systematizing a practice that had been creeping into manufacturing since the 1920s. Light bulbs were the test case. In 1924, representatives from Philips, Osram, and General Electric met in Geneva and formed the Phoebus Cartel. Their explicit goal, documented in cartel meeting minutes that surfaced in antitrust litigation decades later, was to reduce the average lifespan of incandescent bulbs from 2,500 hours to 1,000 hours. They succeeded. By 1940, finding a bulb rated above 1,000 hours was nearly impossible. The consumer goods industry today generates over $1.7 trillion annually in the United States alone, according to market research data from 2024. A significant fraction of that revenue depends on replacement cycles. If a kitchen mixer lasts 40 years instead of 7, the manufacturer loses 5 repeat purchases per customer. If a wool coat lasts 30 years instead of 3, the apparel brand loses 9 sales. If a cast iron skillet lasts a century instead of a decade, the cookware company loses an entire lineage of buyers. The math is brutal and obvious. Durability is the enemy of growth. This is not a conspiracy. It is a business model. In the 1960s, appliance manufacturers began replacing metal gears with plastic ones, not because plastic performed better, but because it failed predictably and was cheaper to produce. In the 1980s, furniture makers began using particle board cores with thin hardwood veneers instead of solid wood. Not because customers preferred it, but because it reduced material costs and ensured the piece would sag or delaminate within 15 years. In the 2000s, electronics companies began soldering batteries directly to logic boards, not because it improved performance, but because it made repair impossible and guaranteed replacement at the unit level. Every one of these shifts was a deliberate trade of durability for recurring revenue. The market optimized for profit per customer lifetime, not product lifetime. Here is what you do. Step 1. Identify categories where pre-1960 designs outperform modern equivalents. Cast iron cookware, hand tools with forged steel heads and hardwood handles, wool blankets with a weight above 3 pounds per blanket, leather boots with Goodyear welted soles that can be resoled indefinitely, mechanical watches with no electronic components, furniture with mortise and tenon joinery instead of dowels or screws. Each of these categories has modern versions, but the modern versions are engineered to a price point and a failure horizon. The older designs were engineered to a performance standard with no planned end of life. Step 2. Source those items from the used market or from the handful of manufacturers still producing to the old standard. For cast iron, look for pieces with a smooth interior surface, which indicates they were made before 1960 when manufacturers stopped machining the cooking surface after casting. Expect to pay $8 to $15 for a 10-inch skillet at an estate sale. For hand tools, seek out brands that were dominant before 1970. The Stanley Bailey No. 4 hand plane made in 1940 will outperform a modern equivalent and costs $30 to $50 on the secondary market. For wool blankets, look for military surplus. A Swiss Army wool blanket from the 1980s, never issued, weighs 4 pounds and costs $40. It will outlast 10 fleece blankets. Step 3. Learn basic restoration. Cast iron that looks rusted and unsalvageable can be stripped in a lye bath, which costs $3 for a pound of sodium hydroxide, and reseasoned with any cooking oil. Submerge the piece in a 5% lye solution in a plastic tub for 72 hours. The rust and old seasoning will lift off as a black sludge. Rinse thoroughly, dry immediately, and apply a thin coat of flaxseed oil. Bake at 450 degrees for 1 hour. The result is a cooking surface smoother and more non-stick than any modern pan. For hand tools, remove rust with a 50-50 mix of white vinegar and water. Soak for 12 hours. Scrub with steel wool, rinse, dry, and coat with a light machine oil. A plain blade from 1940, properly sharpened, will hold an edge longer than modern high-speed steel because it was forged from a higher carbon content. Step 4. Calculate total cost of ownership. A cast iron skillet purchased for $12 and maintained for 50 years costs 24 cents per year. A nonstick aluminum pan purchased for $30 and replaced every 4 years costs $7.50 per year. Over 50 years, the cast iron costs $12. The nonstick pans cost $375. The same math applies to every category. A Goodyear welted leather boot that costs $180 and can be resoled 5 times for $60. Per resole costs $480 over 40 years, or $12 per year. A cemented sole boot that costs $90 and lasts 3 years costs $1,200 over 40 years, or $30 per year. Durability is not more expensive. It is radically cheaper when amortized across the actual lifespan of the product. Step 5. Prioritize categories experiencing the steepest price inflation. According to industry trade data, the cost of base metals increased 18% year over year in 2025. Cookware, hand tools, and hardware are all metal intensive. Leather goods increased 14% as global hide supply tightened. Wool prices climbed 11% as synthetic fiber subsidies shifted production away from natural textiles. If you are going to acquire durable goods, acquire the ones where the input cost curve is steepest. A cast iron skillet that costs $12 today may cost $16 next year. A wool blanket that costs $40 today may cost $48 next year. The window is closing. Step 6. Avoid the trap of bulk purchasing low-quality items. 20 cheap knives do not equal one good knife. They equal 20 pieces of future landfill. The goal is not to stockpile. The goal is to acquire a small number of items built to a standard that makes replacement unnecessary. One 10-inch cast iron skillet, one 12-inch, one Dutch oven, one carbon steel wok. That is a lifetime cookware battery for a family of 4. Total cost, if purchased used, $60 to $80. Total replacement cost if you bought nonstick pans every 4 years for 50 years, over $2,000. Step 7. Teach the next generation how to maintain these items. A cast iron skillet is only valuable if the person inheriting it knows not to put it in the dishwasher. A hand plane is only valuable if the person inheriting it knows how to sharpen the blade and adjust the throat opening. A wool blanket is only valuable if the person inheriting it knows to air it out twice a year and never store it damp. The knowledge transfer is as important as the item itself. Your great-grandmother knew how to keep a knife sharp, how to season a pan, how to oil a hinge. That knowledge was assumed. It is no longer assumed. Write it down, film it, pass it on. Roman engineers knew it. Han metallurgists knew it. Medieval blacksmiths knew it. Your great-grandmother knew it. A thing made right, maintained correctly, lasts longer than the person who made it. The consumer goods industry generates $1.7 trillion a year by ensuring you forget that principle. A 10-inch cast iron skillet costs $12 and lasts a century. A nonstick pan costs $30 and lasts 4 years. The math is not complicated. The industry just hopes you never do it. Subscribe if this kind of information matters to you. Share it with someone who is tired of replacing the same broken garbage every 3 years. The next vault opens soon, and we are covering the $2 powder that eliminates rust on contact and the reason the military stopped issuing it in 1973. I will see you then.